Welcome back to a brand new series of videos. And this time around, we'll be talking about determining excluded variables. Okay. Now, there will be two videos in this installment. The reason I kept it to two videos is because I think the video itself contains 6 or 7 problems. And I think at the end of the two video, I felt I've exhausted the concept to a certain extent. So I felt that'll be enough. But if you feel like you need more, just let me know in the comment box below. I can provide maybe a video or two more on this topic. All right. So welcome back. Let's get started. The first problem is very simple. Essentially, you're applying two different concepts that you've learned before into a single concept, and then you add maybe a little bit of the newer concept to tie it all together, right? So here we have x squared minus 4 over x squared plus 5x plus 6 equals 0. The question asks you, which of the following are answers to the equation below? Okay, so there's two components here. One involves factoring, which is the numerator term, and the other one involves quadratic equations. So let's go ahead and factor the numerator and use quadratic, the knowledge that we got from quadratic equations to solve the denominator. And let's see where we end up with. There will be something that will be common in both. And then if you eliminate the common, whatever is left out is our answer. So what's x squared? X squared minus 4 can be factored as x squared minus 2 squared, which is same as x minus 2 times x plus 2. Remember, a squared minus b squared is a minus b times a plus b. So we know x can be plus 2 or minus 2, right? Remember, when you have a ratio that's equal to 0, both the numerator and the denominator can be equal to 0, right? So that's why I said if this factoring can be equal to 0, that means x can be plus 2 or minus 2. Now let's solve the quadratic expression. We know that x squared plus 5x plus 6 equals 0. We want 6x squared when two terms are multiplied. But at the same time, we want 5x when they're added or subtracted, right? So if we do 3x times 2x, we get 6x squared. If we add 3x plus 2x, then we get 5x, right? So if we substitute 3x plus 2x in place of 5x, then we get x squared plus 3x plus 2x plus 6 equals 0. We split this equation right here. That means it's x plus 3 plus 2 times x plus 3 equals 0. So it's x plus 2 times x plus 3 equals 0. X equals minus 3 and x equals minus 2. What this is telling us is, if we substitute x equals minus 3 or minus 2, the denominator becomes 0, which makes the whole thing indefinite, right? We cannot have a solution if the denominator is 0. So x cannot be negative 3, x cannot be negative 2. If x cannot be negative 2, x cannot be negative 2 here either, right? X just cannot be negative 2. So that means x can only be plus 2. So the answer is 3 only. Did you see what I did? Because we equated the quadratic expression to 0, that means if you substitute negative 3 in the quadratic expression or negative 2, the denominator becomes 0. And if that's the case, then if you divide any value in the numerator by a 0, that becomes 0. Right? So we cannot have negative 2 because our factoring also has two values possible, plus 2 or negative 2. We just simply can ignore minus 2 altogether, which leaves us with the only possible value that's allowed, and that will be x equals plus 2. Right? Think about it. If you substitute, the factoring itself doesn't allow you to eliminate negative 2. It is only with the help of the quadratic expression you are able to eliminate this minus 2 right here. Okay. So this is a very interesting problem, and I thought Well, why not we include it in the session? So that's why I included it. So let's continue. If the arithmetic mean of x, y, and 9 is 12, what's the average of x plus 2, comma, y minus 6 and 10? Well, what do we know about mean? Well, we know something about the first part of the problem, which is x plus y plus 9 equals 12. But we're missing something. That is, we have 3 aspects, so we divide by 3, right? So in other words, x plus y equals 36. X plus y plus 9 equals 36. So x plus y equals 36 minus 9, I believe is 27, right? 27. Well, we can't proceed any further. At this point, we have to stop this right here. And let's go to the second part of the problem. It's asking you for x plus 2 plus y minus 6 plus 10 over 3 equals what, right? So if you shuffle the terms, then we notice we get x plus 2 plus 10 minus 6 over 3. We know x plus y is 27, plus 2 plus 10 is 12, minus 6 is 6. So over 3, 27 plus 6 is 33, right? And that divided by 3 is 11. This is one of those problems where you have to use a skill. If you try to use the answer choice to go back and figure out what it could have been, it's going to take you a lot of time. And time is not something that you always have on a SAT exam, or for that matter, any standardized test. Time flies like that, okay? That's why I'm trying to, even when I do the problems, I try to limit the amount of time I spend on a problem. Only if I feel the problem could use more explanation, I keep the explanation at the end so that, you know, you may have understood the problem as I solved it. But if you're looking for that tip or explanation, you can always listen to it at the end. That's why I don't try to complicate when I solve the problem. I try to do my best to solve the problem as quickly as possible with as much clarity I can provide. All right, so let's continue. Find the excluded values of the following algebraic expression. Again, we can, you know, there's 2 ways to go about it. So 2x squared minus 5x minus 12 over x squared minus 11x plus 28, right? Now assume this is equal to 0, okay? Because I don't think you can solve the problem otherwise. Now, unlike the problem we did just before this one, where the numerator involved factoring, the denominator involved quadratic equation. Okay, here both expressions have the quadratic expression form, so you do not have to solve both numerator and denominator. You can solve the denominator, that'll be enough, because you don't want the denominator to be 0. That's the whole point, right? So if you just solve the denominator, you'll be fine. Whereas in the previous case, you have to solve the numerator as well, because that involved 2 different concepts, one factoring, one quadratic. Here it's both quadratic, so you do not have to solve the numerator at all. You can just focus on the denominator. So what do we do? X squared minus 11x plus 28. So we want equals 0. So we want plus 28x squared. At the same time, we want negative 11x, right? So if you do minus 7x times minus 4x, you get plus 28x squared. And if you add minus 7x and minus 4x, you get minus 11x, right? So we substitute negative 7x minus negative 4x in place of negative 11x, and that'll give us x squared minus 7x minus 4x plus 28 equals 0. If we split the equation right here, then if we take x as a common factor, then we get x times x minus 7 minus 4 will give x minus 7. The whole thing is equal to 0. So if we combine the terms, it's x minus 4 times x minus 7 equals 0, x equals 4 and 7. So what it's essentially telling us, if x were to be 4 or 7, the denominator becomes 0, which means x cannot be equal to 4 and 7 if this were to be a legitimate algebraic function, right? So the answer is x is not equal to 4 and 7. I don't think you can say it any other ways because there's no choice that says x equals 4 and 7. Of course, you could be tempted to use insufficient information provided, but you solved the problem this much, so how can insufficient information provided could be a possible choice? I don't see anything else being the correct answer at all. So that means x not equal to 4 and 7 is the only possible answer and the correct answer, because the denominator at all times cannot be 0, because if it is 0, then the whole function becomes, invaluable, so, or doesn't have any value. So that means x is not equal to 4, 7 is the answer. So let's continue. Again, we have y equals x squared minus 5, and then over x squared minus 25. They're asking for which one of this is a possible answer. So again, like I said previously, we can have the denominator being 0. Since they're both factoring, again, you do not have to focus on the numerator. It's only when it is a factoring and a quadratic, you have to focus each one separately. But when they're both factoring or both quadratic, you do not have to focus on the numerator. You can focus only on the denominator. This means x squared minus 25 equals 0. That means x squared minus 5 squared equals 0. I'm just treating 25 as 5 squared, which means x minus 5 times x plus 5 equals 0. That means x equals plus 5 or negative 5. If this were the circumstance, then the denominator becomes 0. Then the whole function has no meaning, which means x equals 5 or negative 5 those are the excluded variables for this problem. So the correct answer is x equals 5 or x equals negative 5. Does that make sense? Okay. So this question talks about something we've not talked at all before, and that's extraneous solution. Okay. If you solve for the value of x and you put it back into the expression, and if the two values on the left and right side are equal, then that is not an extraneous function. If the value on the left and right hand side are not equal, then that is an extraneous function. Okay, we have to determine what that is. So the only way we can do it is convert the above expression into a quadratic expression, solve for the value of x, and then plug the value x back into the expression, and then see if we get the left and right side to be equal. If it is equal, then it is not an extraneous. If it is not equal, then it is an extraneous solution, right? So let's go ahead and solve it. So we have root x equals 3x minus 4. The best way to approach when you have square root on one side and there's no square root on the other side is to square both sides so that the square root cancels out. So if you square both sides, then we have this as the expression. That means this implies x equals, because these two cancel out, equals 3x minus 4 squared equals 9x squared minus 2 times 3 times 4 plus 16, right? So it's 9x squared minus 4 times 3 is 12 times 2 is 24 plus 16, right? Over x. So if you bring the x to this side, that means it's 9x squared. Sorry, I missed the x here. So it's 9x squared minus 24x minus x plus 16 equals 0, implies 9x squared minus 25x plus 16. This problem cannot be solved by simple factoring of the quadratic expression. You have to actually use the quadratic formula to solve the expression to figure out the roots for x. So in other words, we have 9x squared minus 25x plus 16 equals 0. This means this is A, this is B, and this is C. This means minus B plus or minus root of B squared minus 4AC over 2A equals, it'll be plus 25 plus or minus 25 squared minus 4 times 9 times 16 over 9 times 2 is 18. You are welcome to use the calculator because I think this problem was part of the calculator sections. Typically, you see this sort of problem towards the very end of the test. Those problems are usually lengthy, they're wordy, they may be difficult. All sorts of things usually happen towards the end of a SAT exam rather than at the start or the middle. You find problems of a decent difficulty. So as I'm talking, I'm solving this. So you have this. So 625 minus 576 is 49. So it's 25 plus or minus 49 over 18. It gives you, well, we know square root of 49 is 7. So 25 plus or minus 7 over 18. 25 plus 7 is 32 over 18. And then 25 minus 7 is 18 over 18, right? So that means we can solve this further. So it's 2, 16, 2 9s. So we have 16 over 9 as one of the variable and the other is 1, right? So those are the two values of x. So if you put x as 1 into this expression, why did I pick a 1? Because it's easy to apply to see if it is even an extraneous solution or not. If it is not, then we can move on, right? It makes life easy, right? So root of 1 equals 3 times 1 times 4, right? Root of 1 is 1. 3 times 1 is 3 minus 4 is equal to 1. 1 is not equal to -1. So right away, we know this is an extraneous solution, right? If you're in doubt, you can go ahead and do the other one to see if it is an extraneous solution or not. So you substitute square root of 16 over 9 equals 3 times 16 over 9 minus 4. So this will be square root of 16 over 9 is same as 4 over 3 equals, this would be 3. So 16 over 3 minus 4, that'll be, I think 12, 16 over minus 12 over 3, right? Yeah. That right? 16, yeah, 16 over 9. So that's 3 times 16 over 3. So 16 minus 12 is 4, sorry. 4 over 3. So 4 over 3 equals 4 over 3. So this is not an extraneous solution. So that means we cannot have -1 was not even an answer choice. 16 over 9 is not possible. Or we've solved the problem, so insufficient is not an option. We did determine an extraneous solution as an answer choice, so the correct answer is 1. It's a lengthy problem. Now, I mean, I would say this is as difficult as it gets on this type of concept. So if you see this problem or see this sort of problem on extraneous solution, if you have plenty of time, then go ahead and solve it right then and there. If not, you can save that time for later. You can always come back. It's not that you don't know how to solve it. It's just you have to go through all of these steps to solve the problem. So if you're out of time, then do your best to do it. If not, you can always come back and solve it on an actual test. All right, let's continue. This will be the last problem on this video. I have a few more problems in the second video on this installment, so stay tuned for that as well. So a train travels at a constant rate of 20 meters per second. How many kilometers does it travel in 10 minutes? Okay. What is it asking for? We know speed equals distance over time. So we know time, we know speed, we want distance. What's our speed? Our speed is in 20 meters per second. Whereas our time is in minutes. Either you convert the speed into minutes or convert the time into seconds. I would say time into second is my preference. So this is my speed. Time is 10 minutes, right? So 10 minutes would be same as a minute contains 60 seconds, right? So that means it's 600 seconds. And also what is important to know is the final answer has to be in kilometers, which we'll get to it as we get to it. So distance would be speed times time. So it'll be 20 meters over 1 second, right? Times 600 seconds. We now have our answer in meters, but we want our answer in kilometers. And we know 1,000 meters is 1 kilometer. So if you put it all together, then that's your final answer. So 20 times 60 divided by 8,000 is 1.2 kilometers. That's the answer. So there's just two key takeaways. One is you got to make sure you watch for units. So that's another important thing. Second thing, you have to know which term to put at the top, which term to put on the bottom. Terms that you want to cancel out always go diagonally across. As you can see, I'm always canceling terms that are diagonally across. That's very critical. In other words, it has to be, it cannot be next to each other. It has to be at least at best one above each other. So that's the only way you can solve this sort of problem. So this is the end of the first video on the topic of determining excluded variables, and I'll see you with another video with more problems on this topic. So stay tuned, and if you've enjoyed watching this video, you learned something, please subscribe to my channel, share the videos with your family and friends. I'll see you with another video. All right, so stay tuned.